Okay, so Chapter 9 only has 2 sections that we're going to go over. This one deals with operations of functions. These are not hard unless you don't pay attention. Then they can get a little bit tricky. All right, so the first thing we're going to discuss is adding and subtracting functions. All right, so I've given you 2 functions. I've got f of x is 5x minus 6, and g of x is x squared minus 5x plus 6. And we're going to talk about what this means. This is not f plus g times x. You know how this is g of x? It just represents a y. This is just telling you to take the f of x and add it to the g of x. It doesn't mean take f and g, add them, and multiply by x. So I want to make that very clear. You are not multiplying by x. This is just notation. Okay, it's just how it's written. Just like this is f of x, that's function notation. Same thing with g. Make sure you understand that. All right. So this just means I'm going to take the f function, which is this function right here, and I'm going to add it to the g. All right. And we've kind of done some things like this before. So f is 5x minus 6. So I've got 5x minus 6. And I'm going to add that to the g. So that's x squared minus 5x plus 6. All right, and if you'll remember, we have already done this before. This is not new to you. All right, if there's nothing in front of the parentheses to distribute, then you don't need the parentheses. So I'm going to take them off. So this is just 5x minus 6. And again, nothing here in front of this parenthesis to distribute. So I'm going to just take the parentheses off. So this is a positive x squared minus 5x plus 6. We always put things in standard form, meaning biggest degrees first and your constant at the end. So, all right, so our biggest power is this x squared. There's no other x squared, so x squared goes first. I like to mark it out as I go, so I'm done with it. Next would be the 5x. So I have a 5x and a negative 5x. That just makes 0, so they cancel. And then I have negative 6 and positive 6. That also makes 0, so those cancel. And so my answer is just x squared. So it's mainly just combining like terms. All right, so this is the same thing, only instead of adding f and g, we are going to subtract. Again, we are not multiplying by x. This is just a notation. All right, so I'm going to take the f function. That would be 5x minus 6. And I'm going to subtract the g. So that would be x squared minus 5x plus 6. All right. And again, this is like what we talked about earlier in the year. If there's not anything to distribute in front, then you don't need the parentheses. So we take those off. This has a negative to distribute. Remember, when you distribute a negative, all it does is it changes the sign of everything that follows. So if I distribute a negative to this x squared, that's going to become negative x squared. If I distribute a negative to the negative 5x, that becomes positive 5x. And if I distribute a negative to the positive 6, that becomes negative 6. Now I just want to put everything in standard form. So I start with my biggest degree. That would be this negative x squared. So I've got negative x squared. Nothing else would go with that. Next highest degree would be my 5x. So 5x and 5x, that's 10x. And then negative 6 and negative 6 is negative 12. And I am finished. So adding and subtracting, really not that bad. So now let's talk about multiplying and dividing. I'm giving you two new functions. All right, this f of x, this is going to be your g of x. This is just g times f of x. Remember, we are not multiplying by x. We are only taking the g and multiplying it by the f. So, g is 2x minus 2. So I've got 2x minus 2. All right, f of x is 2x squared plus 4x minus 6. Now all I have to do is multiply those. So I've got to take this 2x, I'll use a color for that, 2x times the first thing. So 2x times 2x squared, that would be 4x to the third. 2x times the next thing, so 2x times 4x, that would be 8x squared. 2x times negative 6 is negative 12x. And so now I have taken that first thing times all three terms right here. Now I will do the second thing. So I've got negative 2 times 2x squared. That's negative 4x squared. Negative 2 times 4x is negative 8x. And negative 2 times negative 6 is positive 12. All right, now that I have everything all multiplied out, I'm ready to combine like terms. So my biggest degree here would be the 3. So there are no other x cubes. So I've got 4x to the third. So I'm done with that one. All right, I have a couple of x squareds. I have 8x squared minus 4x squared. That would be 4x squared. All right, next would be the x's. So negative 12x minus 8x is negative 20x. And then the Lone Ranger back here is just 12, so I'll add the 12. And I'm in standard form, and I'm done. So nothing new here. The only thing new is the notation. Okay. Now let's try one that's dividing. So I have to take the f and divide it by the g, remembering that I am not multiplying by x. So f was 2x squared plus 4x minus 6. So I've got 2x squared plus 4x minus 6. And I'm going to divide that by the g, which is 2x minus 2. Okay. Now, there's always things that you want to notice. So, for instance, if you notice, every single term is divisible by 2. Is it always going to work out like that? No. But in this case, it's going to make things easier for you. So go through and divide everything by 2. So if I divide 2x squared by 2, that's just x squared. If I divide 4x by 2, that's just 2x. If I divide negative 6 by 2, that is negative 3. On the bottom, 2x divided by 2 is just x, and negative 2 divided by 2 is negative 1. Okay? Anytime you see an x squared, an x, and a constant, you should be thinking that you're probably going to factor that. All right? And in this case, you are. So I'm going to factor this. The minus in the back tells me that I should have 1 plus and 1 minus. X in front means I should have x and x. And then I need two numbers that will multiply to make 3 and subtract to make 2. That would be 3 and 1. Since I have two different signs here, I look at the front. I need to get a positive 2x, so my big number will go with the positive, and my other number will go with the negative. That's all over the x minus 1. Now, if you notice, I have a factor of x minus 1 on bottom. I also have a factor of x minus 1 on top. They will cancel. And all that leaves me with is x plus 3. On the ones where you are dividing, most of the time, you're going to have a factor on top that matches that factor on bottom. And that's something to really remember for the test at the end of the year. It will help you tremendously if you remember that. All right? So x plus 3 is your answer. All right. We're going to talk about composition of functions, okay? Something that we need to point out here, okay, is this little symbol right here, this circle right there. Make sure that you know this is not, I repeat, not multiplication. Not multiplication, okay? It is an open circle, okay? Multiplication symbol is closed in. This is the same thing as this, and you read this, f of g of x, all right? It's the same thing if you had f of x, but this is f of g of x. Same thing here, f of g of x, okay? This is not multiplying the f and the g. This is just a notation. And this is the notation that you will see more often than this one. But you need to know both of them in case they throw one your way. So, f of g of x. All right? Let's get some practice with some composite functions. So again, I've given you a fresh f of x and a fresh g of x to work these problems. All right? So we're going to start with something basic. You always work from the inside out. Okay? So these are not hard, but if you don't pay attention, they're a little bit weird. Okay? So the very first thing I'm going to do is this g of 2. That is on the inside. Okay? So let's figure out what g of 2 is. And remember, this just means that I plug 2 into the g, okay, for the x, all right? So this is g of x, is x to the third. I am going to plug this 2 in for x. So that gives me 2 to the third power, which is 8. So g of 2 is the same thing as 8. So if something is the same thing, that means I can replace it, right? So instead of saying g of 2, I'm just going to replace that with an 8. So now instead of f of g of 2, I have f of 8. So now I have to figure out what f of 8 is. Well, I've got to plug 8 into the f function for this x right here. So that gives me 3x plus 1. I'm going to plug in 8 for this x right here. So I have 3 times 8 plus 1. If I work that out, that gives me 25. So the answer is 25. So first find this part. What your answer is for that will then go in for this. So you start on the inside and work your way out. So for this one, if I start on the inside and work my way out, that means I'm going to start with f of 2. So I want to figure out what f of 2 is. So I'm plugging 2 into the f function for x. So that means I'm going to plug it in right there. So that gives me 3x plus 1. I'm plugging in 2 for x. So that gives me 3 times 2 plus 1, which is 7. So instead of saying f of 2, I can replace that with 7. So now I am trying to find g of 7. So I go to my g function, and I'm going to plug in 7 for the x. So g is x to the third. I'm going to plug 7 in for the x. 7 to the third power is 343, and that is my answer. All right, we're going to do a couple more of these with a new f of x and a new g of x. So here is your new f of x. Here is your new g of x. And we have two new problems. So the first thing I start with is the inside, g of 3. So I have to find g of 3 first. All this means is I'm taking 3 and I'm going to plug it into the g of x function for the x. So g of x is x squared. I plug in 3. 3 squared is 9. So instead of saying g of 3, I just replace that with a 9. So now I am trying to find f of 9. So I go to the f function. I'm going to plug 9 in for x right there. So I've got 2x minus 3. I'm going to plug 9 in for x. 2 times 9 is 18, minus 3 is 15. That is my answer. All right, one more of those. We're going to start with the f of 3. So that means I'm going to go to the f function and plug in 3 for the x. So f is 2x minus 3. I'm going to plug 3 in for that x. So that gives me 2 times 3 minus 3. 2 times 3 is 6 minus 3, which would just give me 3. So instead of saying f of 3, I can just replace it with 3. So now I am trying to find g of 3. That means I'm going to go to my g and plug in 3 right there for that x. So I get x squared. I plug in 3 for the x. 3 squared is 9. And that's my answer. You need this basic composition to do the more complicated stuff. All right? So here we go. So we are given two functions. F of x is equal to f5x plus 2. And g of x is equal to 2 over x minus 1. It wants us to write each composite function and state the domain of each. Not the range, just the domain. And when it talks about stating the domain, it just wants to know what x cannot be. All right? And the only time we worry about what x cannot be is if we have an x in the denominator. So we'll want to be careful with that. All right? Now, like I said, these are not difficult unless you don't pay attention. Okay? Got to pay attention. All right. So this is how this works. You always start with the inside. So this g of x is going to go into the f function for the x. All right? So g of x is 2 over x minus 1. And we're going to take that and put it in for this x right here. So this is what I want you to do every single time. Whatever you're going to be plugging into, which in this case we're plugging into f, it's always this one that's on the outside. We're going to write that down, but instead of putting an x, we're going to put a big parenthesis because we're going to plug in for that x. So I would have 5, and then instead of x, I'm going to put a parenthesis, and then after that you've got plus 2. So the only thing you're not writing down is the x. All right? And in place of that, you're putting the g of x, which is 2 over x minus 1. So you're replacing with this part right here. Now all you do is simplify. So I've got 5 times 2 over x minus 1. All right? This is like 5 over 1. You multiply tops, you multiply bottoms. 5 times 2 is 10. And then I've got 1 times x minus 1, which is just x minus 1. And then you've got plus 2. I cannot do anything else with that. I have simplified as far as I can. But now we have to think of what x cannot be. I have an x in the denominator. That's a problem, all right? And it's a problem because I can't have a 0 in the denominator. So we're going to look at this bottom part, okay? Whatever this bottom is, you're going to set it equal to 0. And you're going to solve for x. That's going to tell you what x cannot be. So if I solve for x, and you know what, why don't you write out here that this is working your domain so that you know what you're doing. All right? So I know that x has to be 1 if I want to get a 0, which makes sense. If I plug a 1 in right here, 1 minus 1 is 0. Can't have a 0 in the denominator. So my domain is that x cannot be 1. So my answer would be 10 over x minus 1 plus 2. And then I'm going to state my domain. X cannot be, so we'll put an equal with a slash 1. That's just because we don't need a 0 in the denominator. Can't have it. All right? So now let's talk about 10. Instead of plugging g into the f, we are going to plug f into the g. So the one that I'm going to write down will be the g. But instead of writing down the x, I'm going to put a big parenthesis. So this gives me 2 over parenthesis, and then I've got minus 1. This is going to help when you have big, long problems with more than one x. All right? So now in that place, I'm going to put 5x plus 2. Now all I have to do is simplify. Well, there's nothing to simplify on top, so I'm just going to write that down. All right, I have parentheses here, but there's nothing in front that would need to be distributed, so I really don't need the parentheses, so I'm going to go ahead and take them off. And then I notice that I have a couple of like terms on the bottom, so 2 minus 1 is going to give me a 1. So I get 2 over 5x minus 1. All right, that's as far as I can go. Plus 1, sorry, plus 1. That's as far as I can go. But I do have an x in the denominator, so I have to set that x equal to 0. If I set this equal to 0, I'm just going to put a D for domain. I'm going to set it equal to 0. I would have to subtract the 1 and then divide by the 5. So x cannot be negative 1/5. X cannot be negative 1/5. If I plug in a negative 1/5 right there and multiply it out, I'm going to end up with a 0 in my denominator. So x can be everything except for negative 1/5. All right. A new f of x and a new g of x. I'm going to throw in a little square root action for you. All right, so the first way we're going to go is we're going to plug in g for the x and the f. So I'm going to write down the f because that's what I'm plugging into. But instead of writing the x, I'm going to put, let me go back. Instead of writing the x, I'm going to put a parenthesis in its place. So parenthesis, and then you've got minus 4. And in that place, I'm going to put what the g of x is, which is square root of x plus 2. All right, then I just have to simplify. So I'm going to have to distribute 3 times x squared is 3 times the square root of x is 3 square roots of x. And 3 times 2 is 6. And then back here I've got minus 4. These are like terms. 6 minus 4 gives you a 2. So I get 3 square roots of x plus 2. Now I think I stated earlier that we worry about the domain when we have an x in the denominator. We also worry about it when x is under a square root. So under a square root, x can be 0, okay? I can have a 0 under my square root, but I cannot have a negative number. That would give me an imaginary number, and we would have a non-real result. So we have to think about the types of numbers that we can plug in for x. Well, first thing you want to do is you want to say, well, what would make underneath equal to 0? So if I set the underneath part equal to 0, I don't have to do any solving, but this is the number I'm going to use, all right? And I'm going to have to do an inequality because here's the deal. X can be positive numbers, but x cannot be negative numbers because then I would have an I. So that tells me that x has to be greater than or equal to 0. That's going to be your domain. All right? Okay. Now let's take a look at the opposite direction. We are going to plug the f of x into the g. So I will write down the g, okay? But instead of putting x under the square root, I need to leave space because I'm going to plug this in. And then on the outside, I've got the plus 2. So I'm going to plug in 3x minus 4, where that x was at. And I can't do anything else because 2 is on the outside of the square root, so there's nothing to combine with it. But I need to think about what would make this equal to 0 underneath. Remember, it can be 0, but it can't be negative. So for the domain, let's set this underneath part equal to 0. So I would have to solve for x. I would add 4, and then I would divide by 3. So to make x equal, or to make that whole thing equal to 0, x would have to be 4/3. So 4/3 is a little bit over 1. All right? So let's pick a number that's either bigger than that or smaller than that, and that'll tell us what values of x have to be under our square root. So let's pick 0. 0 is smaller than 4/3. So if I were to plug 0 in, I would get 3 times 0, which is 0, minus 4, which is negative 4. That would give me a negative number. So I can't pick numbers that are smaller than 4/3. So that means all of the numbers I pick have to be greater than or equal to 4/3. All right? So you always use this number right here, but you have to decide whether the values can be bigger or smaller. So since 0 did not work, that tells me they can't be smaller. They have to be bigger. So x has to be greater than or equal to 4/3. All right. And that's about all I've got. Now, I do need to point a couple of things out. Let's say that you end up with something like this as your answer, okay, after you've done all your compositions, okay? If you don't have an x under a square root or in your denominator, then there's nothing that x cannot be. So let me reiterate. If you don't have an x in the denominator and there is not an x under a square root, then your domain will be all real numbers. You can just write the little double-staffed R. That represents all real numbers. All right, as long as you have an x in the denominator or under a square root, you have to think about what x cannot be. Okay, so if you don't have either of those two situations, then x can be anything, and you can just write all real numbers.